Statistical inference. Statistical inference is concerned with generalizations or making inferences about the population on the basis of information contained in the sample. They are also called inductive reasoning or inductive inference. There are two kinds of inferences. One is inductive, while the other is deductive inference. Inductive inference involves uncertainty in conclusions. One cannot make perfectly certain generalizations on the basis of experimentation. However, the degree of uncertainty can be measured in inductive inference. In statistics, uncertainty is measured in terms of probability. Deductive inference is a method of deriving information from accepted facts. It involves no uncertainty in the conclusions. While deductive inference is extremely important, much of the new knowledge in the real world comes about by the process of inductive inference. Statistical inference makes judgment about the particular parameters on the basis of sample statistics. These judgments are mere guesses and reliability can be increased with different sampling techniques. The judgment relating to population parameters are of two types. One is concerned with estimation of a parameter, the other with testing some hypothesis about the parameter. The estimation is done with the help of an estimator. Estimator is a formula which describes a procedure of obtaining the value of given population parameter. A specific value of this parameter is called estimate. On the other hand, hypothesis testing involves an a priori assumption about the value of a parameter. The hypothesis is tested against the information provided by sample in the form of a test statistic. In statistical inference, we are therefore concerned with the value of an estimate or of a test statistic, which in turn represents a guess concerning the relevant population parameter. Different samples would lead to different guesses, that is, some values will be close to the value of the parameter than the others. But in reality, we deal with only one sample and therefore we obtain only one value or guess. Nonetheless, it is also important to know what the guesses might have been had we had different samples from the population. There could be three possibilities. A. That all the possible samples lead to guesses which are always the near true value of the parameter. B. That all possible samples lead to widely different guesses and only few are near the true value. And C. That all the possible samples give rise to the same values, but these are far from the true value of the parameter. In the first case, any sample value is obviously quite reliable. In the second, only some of the guesses can be near the true value, but in the third case, no guess can be found to be true for the population parameter. Various methods are used for making statistical inference. These methods are based on the following four situations: the population as it actually is, the relationship between characteristics of this population and characteristics of many samples drawn from this population, the relationship between characteristics of many samples and the characteristics of one sample, and the sample that one actually observes in practice. Now suppose our problem is to infer from the observed sample, which is situation 4, the characteristics of the true but unobservable population, which is situation 1. To do this, we make use of the laws provided by situations 2 and 3.